Git for ages 4 and up. So if you are under the age of 4, please leave the room. Trying to create more space. Michael Schwan. Michael Schwan has got a copy of Perl 6. I remember a talk on Perl 6 at the Dunedin conference in 2006.
10 years ago.
Yeah, okay. He lets Larry Wall borrow it and take notes. He once sneezed into a microphone, and a text-to-speech conversion was a regex that turns crap into gold. Very good. These are great skills. I think I am going to, unlike most bios, I am going to read most of this one out because this one's actually funny. Damien Conway and Schwern once had an arm wrestling contest. The superposition hasn't collapsed. Schwern was the keynote speaker at the first YAPIC Mars. When Schwern runs a spoke test, the fire department is notified. Dan Brown analysed a JPH Schwern wrote and discovered that it contained the Bible. Oh. Schwern writes Perl code that makes make files that write shell scripts on VMS. That's true. That's good. Schwern does not commit to master, master commits to Schwern. SETI broadcast some of Schwern's Perl code into space. 8 years later, they got a reply thanking him for the improved hyperdrive plans. Schwern once accidentally typed git pull hard and trade GitHub's server room across the street. There are no free namespaces on CPAN, there are just modules Schwern has not yet written. Schwern's tears are said to cure the cancer. Unfortunately, his Perl code gives it right back. On that basis, on the basis of that introduction, can we all give a very warm welcome to Michael Schwern doing Git for ages 4 and up. Thank you very much.
I never actually had that bio read out loud. So hello, this is Git for ages 4 and up. I'm Michael Schwern. LCA has graciously flown me in from the wilds of Portland, Oregon. And I'd like to thank, first off, the AV people for dealing with my special requirements and my panic. So this is a double session, so we're going to be in here for a while. This session is for, if you've never used version control before and you've never used Git before, probably is one step past. This is for people, so sorry about that. This is for people who have been using Git and you have some issues with it. You've used it, but you don't really understand it. You don't feel confident. You kind of learned it by rote. You know, it's just a pile of commands to you. If you get into trouble, there's some Git expert that you call to get out, or maybe you learn like the one command to reset everything. So you can add, you can commit, maybe you can branch and merge. Maybe you can push and pull on a good day, but it all kind of goes pear-shaped when, you know. So this is the set of commands that I expect you to have a familiarity with. Init, add, commit, branch, merge, push and pull, those are the important things. So people are just coming in. If you want to, you can settle down in the front row. I can pull this thing back a little bit. There may be a little bit more room over here. Get comfortable. Actually, people can sit over here if they want. You'll be able to see what's going on. You may not be able to see this, but you'll be able to see this, which is the fun part.
Actually, I might have to jump in here and say, you know, that these rooms do actually have fire regulations and quantities of people, so maybe we're about right. No more.
Yeah. No room at the inn. No room at the inn, sorry.
Watch it on YouTube later.
Okay, yeah, this is the first time this will be fully recorded and you're seeing the upgraded best version of it. All right, so why is Git so darn complicated? Now, first off, it's not you. Git is really complicated. Like, it took me a year or two to figure it out, and I've used probably 6 different version control systems. So I have a hypothesis. Git was written by kernel developers for Linux kernel development. Now, are there any kernel developers in the room? 1, 2, okay, well, you might be mobbed. And the problem is kernel developers are very comfortable with complexity. That's the actual network flow through the Linux kernel. They're not known for their stunning user interface design. And it was written by some guy in 3 weeks. And he said, I really designed it coming at the problem from the viewpoint of a file system person. I have absolutely zero interest in creating a traditional source control management system. How many file system developers are there in the audience right now? Raise your hand. Yeah. Thanks, Linus. The commands don't really make sense unless you understand what is going on under the hood. What is going on internally. And normally this is a huge red flag. Do not use this software if you have to understand the internals. But turns out it's easier to understand Git from the inside out. This is because the interface is so bad, but it's also because the internals are so good. They're really good and they're really simple. Problem is, whenever anybody starts to talk about the Git internals, they start talking about the DAG. And that means directed acyclic graph. And they start talking about nodes and trees and commit objects and checksums and not doing it for me. Right? How many people here understand what a directed acyclic graph is? All right, more than I thought. Okay. But still less than half. So it's really very simple. And I know that when a programmer says it's really very simple, it's time to clear the room. But it's really very simple. Git only knows a handful of tricks. And the commands really just recombine these 4 or 5 tricks over and over again. The unfortunate part is that the commands give you no real indication as to what they're actually doing from the man pages or from the name or anything like that. So once you know them, everything makes much more sense. And I can teach them to you using these, children's toys. They're wonderful advanced computer science tools. So let's begin. So in order to do anything in Git, first thing you've got to do is you've got to init. Git commands, there's a lot of Git commands. There's dozens and dozens and dozens of them. But they can basically be broken down into a handful of categories. So init and clone are how you start a repository. And let me get set up here to start switching back and forth. Oh dear. Pardon the AV issues. There we go. Great. Okay, so when you init a repository, Git says initialize empty Git repository in blah, 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 blah. Here's our repository. And what Git has done is has created a .git directory. And inside that .git directory is a whole bunch of junk. Actually, there's a whole lot of nothing right now because it's an empty Git repository. And the important thing to realize is that this is the entire repository. There's no server, there's no daemon, there's no talking to anybody else. You type git init and you have a complete Git repository sitting right there in your directory. Which means that you can shove anything you want into Git. I do it all the time. This talk is in Git. So it's very easy. So, if we can't, that's not very useful. So let's move on to, where is my cock? Okay. Talk about .git directory. So here are the 2 commands for getting stuff done: add and commit. Let's illustrate them. Oh, I need a minion. Got a minion to push a button?
Minion.
Yep, okay. Minion. What's your name, Minion? Oh dear. Julius, you will be the button pusher.
There's lots of buttons.
You're going to switch between the document camera and the laptop.
Okay.
So switch to the document camera, please. Oh, yay. Okay, great. So let's do an add, and you'll just have to switch back to the laptop, please. Sorry about that. All right. So let's write a file. Is that too low? Can everybody see that down that? I'm going to raise up a little bit just in case. There we go. So we'll write a file. This is a line in my file. Save that. Now, the first thing you have to do is tell Git, hey, add this file. Now what add does is add writes to the repository. It's at that moment it has written your file to its repository in a thing called a binary object. That's very important to understand, and we'll talk about more of that later. Add writes things to the repository. Second thing we have to do, switch back.
Bit of latency.
What's that?
There's a bit of latency.
Yeah. Is commit. So it's weird because we've already written to the repository, so commit isn't actually writing to the repository. What commit is doing, and now commit asks, hey, what are you doing? Just added foo to the repository. Here's what commit has done. Commit has taken what it's already written to the repository and created a commit object for that, which has an ID. And then it put labels on it. Head and master. So commit does add writes things to the repository. Commit creates a commit object and sticks labels on it. This is the branch. This is where you currently have checked out. You just seen like 80% of Git. But we'll do it again. So let's change this file. All right. Now the interesting thing is at this point Git has not looked at this file at all. So if I do a status, it tells me that foo has been modified, but it hasn't actually written this thing. So Git, when you add stuff, actually writes the file. Yes? You have to ask people to leave?
Way too full. Can people please, in the stairwells, please exit the room? I'm sorry, but I did raise this.
We are taping.
We are taping. You can see it on YouTube afterwards. I did mention that.
Forever and ever, you will see us sadly eject.
I'm very sorry about this, but you know, we do actually have to follow the rules concerning fire. You would be really upset if you all died in a fire.
I will happily do encore presentations outside on Friday or something.
And
I'm here
it goes on both sides as well, thanks. If you aren't sitting in a chair, you have to leave. Except for speakers, obviously.
And me?
Yeah, you're all right.
All right. So we've edited foo, and now we have to tell Git that we've edited it. So we add it, and that tells Git, all right, take a new copy of this file.
My brain just broke.
Already? So add has already written a new copy of foo to Git, right? But all of our labels are still down here. So now we're going to commit, and you know, my terrible commit messages, and now it's told me that we have created a commit object and moved. Painful. Created a commit object out of that add, and we've moved the labels. That's it. That's what add and commit do. Would like to see it one more time? What do you think about it? Yes?
What did the add do?
The add,
I mean,
let's do it again.
At which state did it put the object in there?
So let's run through it one more time. It's a little difficult when we're switching. So right now, what Git has stored is the copy is this file. And when I edit it and save it, Git still has that original file in there. When I do a diff, the diff is between what's on the disk and what's in the repository. So when I do an add, now, switch, please. Now that's when Git writes.
So we're getting hung up with differences with every other version control system. All of a sudden, add is different from...
The commands are all different from what you understand in other version control systems. Yeah, add doesn't really do what does in Subversion. Commit doesn't really do what does in Subversion. It's kind of a throw that all out the window.
Yep.
Add. So let's commit this. Just show this one more time. commit. Illustrating add again. So now that I've committed, switch. This has already been written, so Git attaches a commit object to it. That's what I'm representing by turning it around. Now it has an ID. And it moves your current branch and your head, which is what you have checked out, forward. That's it. This is a remarkably accurate model of what is going on inside Git. I'm only taking things away. I'm not making this up. This is nodes and trees and everything else. Yes, question?
I was just going to say, those are nodes.
Yes, commit object, references in the Git parlance. Strangely enough, this will become more obvious when we start branching. What's branch? How many people here are terrified of branching? Raise your hand. Yeah, a good number. Okay. Branching in Git is super easy compared. So I was explaining before, the Git model looks like this, and we'll see what branching looks like. If you have I made a mistake. Can never have the same ID twice. Sorry about that. If you're used to Subversion or CVS, you might think of their model as like a big stack of pancakes, right? You're just kind of building up and building up and building up and building up. And how do you think about branching in a big stack of pancakes? You don't. Yeah, you don't. It just sucks. So let's make a branch and let's call it feature. Git branch feature. So switch. Here is branching in Git. Doink, branch. That's it. Just stuck a new label on it. Now, when we check out, and I'll leave it there. I'm typing git checkout feature. What checkout does is checkout now switches which branch it's going to advance when I commit. So now I've told it by checking out feature, I've told it, all right, when I commit, move the feature label. Also, if they were in different places, it would, get the files and everything. So now, switch. When I, let's say I add a new file. So I'll add, switch. And stick in another add, right? Because add writes the file to the disk at that point. And then we'll commit. So if I do a git status, it'll tell me, I have a new file and to commit. So now, before you switch, what Git has told me here is, there's a lot of information in here. It's told me I'm on the feature branch now, and it's also told me that I'm using, this is the commit ID that it's just committed, that it's just made. And we'll talk about IDs in a moment. Switch. So that commit, just like before, Git takes what I've written with the add, creates a commit object out of it, moves the feature label, moves head. That's it. That's branching.
So head always points at what you've currently got checked out?
Yes, head always points at what you currently got checked out. So I'm going to pause here for a moment and go back, switch, to the presentation.
Are these objects in whole directory then, not just particular files?
What about?
These A, B, W, and R.
Yes.
They're actual the directory, not just particular files. They're different files now.
Oh no, these are commit. Let's talk about IDs. Let's see. We kind of skipped ahead a little bit. Here we are, IDs. So a really important concept in Git is the ID, is the commit ID. And what this thing represents, this ID, this identifier here, which I'm representing as just ABWK, but in Git it's, A429864, blah, 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 blah. This is a checksum of, and a checksum is where you take a whole bunch of data and you do some cryptographic magic on it, and you create a small string that uniquely identifies that. So that if you change the data, even in the slightest, the checksum completely changes. So this is a very easy way to know whether or not you have the same data. You take their checksums and then you compare them. So Git, you relies very, very heavily on this. Anybody need that explained again? Okay. So the ID is actually a checksum of a bunch of things. It's the content of the commit, so the files and everything. It's the author, the date, the log message, and the previous commit. Yes?
When you say previous commit, you mean previous commit ID?
Yes, previous commit ID. And that gets very important later. But what it means is that every ID is unique. Why I made that goof earlier. Every commit is unique. You can't have the same commit twice in Git, ever, in the same repository. Commits never change. Because if they were to change, the content would change, the ID would change, and then everything would go pear-shaped. These are all completely immutable. They never change. So when you've heard about Git rewriting history, that's a lie. And we'll get into that later. So that's what I want to say about IDs. Pardon me about flipping a little out of order. So these things are, they're commit objects that point at the files that are stored into Git. They have all sorts of stuff underneath it. If you want to know more about that, I'm not going to get into how Git stores files because I don't have time. I'll have some books at the end that explain tree objects and everything else. But all you need to know is that this holds on to the content, the author, the date, and the previous commit, and the log message.
So that content could be any number of files.
Yeah, that content could be any number of files at all. And in fact, this one is, in fact, the content of bar and foo. Yeah. I also want to talk to you about the staging area, or the index, or the cache, depending upon what part of the documentation you're reading. I like to call it the staging area because it kind of explains what it does. It's where you prepare things to be written. It's this, you stage them. It's like a staging server. So the staging area is that when you add something, I'm not going to, don't flip. When you add something, when I illustrate it as this is actually Git writing to what is known as the staging area. And you might see that all over the documentation, staging area, index, everything else. And then when you commit, Git takes the content of the staging area and adds an ID. The staging area is interesting because it allows you to build up commits. It allows you to, say, I've changed 6 files, but these 3 changes are really one thing, and these 3 changes are really another thing, so I can add a little bit of it, commit that, add a little bit of it, and commit that. I'll illustrate that later. I'm getting a little bit off track. Let's get back to branching, merging. Where are we at? Here we are. So we talked about branching, which is just adding a label, and we talked about checkout. Well, we didn't talk about checkout. Checkout is basically saying, hey, check out this other label and move head down to there. Pull this out of the repository on disk. So the basic Git workflow looks something, it's not useful to you, looks something like that. You branch, you check out, you edit your code, you test, you add, you commit, and then you pull in some updates from master and you test. So let's do an illustration of that. And actually this is a little bit easier to understand like that. You isolate your work from everybody else's work or your own work. You do your work, you pull in updates from other people, and you share it. That's the basic Git workflow that appears everywhere. Where are we at? Merge. Okay, so let's do a merge. Let's do a few merges. So let's say that our feature is complete, and we only need to really do one thing. So what we can do is we can say git checkout master. So now we switch to master. That means that the head moves down to here. This becomes inactive, This becomes active. And I can see if I do an ls, bar is gone. Git has pulled this onto disk. Now if we say git merge feature. All right. Git has performed the merge. It has told us that it is updating from this commit to this commit. That's what that gobbledygook dot dot gobbledygook means. And it's told us that the way it's done the merge is by a fast forward. So Git has realized that, hey, feature is right above parent. I don't need to do a merge. All I need to do is this. Done. That's a fast forward. You'll see fast forwards oftentimes. No merge necessary. Pretty cool. So let's do a more interesting merge this time. Yes?
I don't get how the this last bit, I didn't get it. How master and feature go back together. I'm sorry.
Okay, let's back up. Okay. I just did a fun little command that allows you. Reset is basically all about moving labels around arbitrarily. So what I basically said is, hey Git, move the current label, master, to head -1. And hard means also do a checkout, and so everything is back to normal. So we're back where we were before we did the merge. That's the important thing. I'll talk a little bit about reset later. Let's show you this graph. Pretty all. Okay. Nope, that's not what I want. Let me check my notes. Decorate. This is a handy little command. Graph. Git log graph decorate all. That shows you, looks a bit like that, don't it? So you see here, these are, down the left-hand side is my line. They've got, each of them have a commit and an ID. So this is D51CD blah, blah, blah. This is B08. This is 8948. And this is F3E. They have their labels. You see head and master here. There's head and master on B08. There's feature here. There's feature on D51. So when I say this is a remarkably accurate model of what Git is doing under the hood, I mean it. So master is here. Feature is here. When we do our merge, git merge feature, switch. So what's going to happen is Git goes, all right, I need to merge this and this. It looks at this and says, well, this commit is right below here. There's no change. There's no it's an ancestor. And it says, all right, well, I can just merge these two things by doing that. Follow? And then head moves up as well, because that's what's checked out. And that's it. That's fast forward. Switch. Okay, so let's do a more interesting thing. Let's switch to back to feature. Check out feature, and this does absolutely well. That and that. And then let's edit. Let's edit foo a little bit. Right. Let's add. Oops. So that creates a new node. Excuse me. And then we'll commit that.
Hold on, I've seen you.
So that's been committed. And switch. So we're working on feature. So feature moves up with the commit. Head moves up. And now, switch. Let's check out master. So master is now active. Our head moves down here. And we can see that bar does not have our new feature. So let's say that, like, you know, somebody's working on the feature, or you're working on a feature, and then somebody comes along and they're like, do this thing right now. So you would check out your master. You would add your, you know, I don't want to get into a conflict yet. This is a bug fix in master.
Is feature still active?
No, we checked out master.
So it should be blue.
Oh, thank you. Yes.
More efficient.
There we go.
You can do this on a computer.
So speaking of the staging area, when I've done a status here, because I've edited this file, Git tells me these are changes not staged for commit. They're not in the staging area, they're just sitting on disk. Once I add bar, status will tell me changes to be committed, which is to say these are changes that are in the staging area. So that's his way of, again, confusingly explaining to you that stuff is in the staging area and stuff is not. So now that we've added, here's where Git's beautiful branching model comes into play. How does Git branch? Well, like that. It looks remarkably like a branch. And then, just as before, if we commit our quick fix to the bar, and again, it tells us it's committed to master. So just like before, staging area gets committed, gets an ID, head moves forward, master moves forward. So now we've got a more interesting merging situation because they diverged. They're doing two different things, and now Git can't just, you know, move one over to the other again. Yes. So let's switch. So now we want to merge the feature into master. So we'd say git merge feature, just like before. Master's already checked out. So what's happened here at this point is Git's asking us for a commit message because it is actually making a commit. Git has basically noticed that these two things are different. I'm gonna do it right now. So we'll switch over to the thing. They've noticed that they're different and that it can't just do a fast forward. And it's now merged them together, written new files, stored them in the repository, and committed them just like any other commit. And it's told us this, merge made by the recursive strategy on the command line. Switch. So what has happened is, did my trigonometry wrong here. There we go. I think that's still wrong. Oh well. So what's happened is Git has written a, yes. Git has written a new commit that merges the contents of the two previous ones, sticks them together into a new thing, writes that to the repository, gives it a commit ID, and then moves master to that.
Feature as well?
No, should not move feature.
And it needs to be another commit
Yes.
because it's neither of the two, it's a combination.
It's because it's new content, and because a commit is its content, its log, its author, its date, everything else. It cannot change this. It's a totally new thing, it needs to be a new commit. Switch. So looking at that, at our Git log, we can see it mirrored here. Here's D143 at the top with its head and master, and then it shows it branching into 141, which has feature still on it, feature doesn't move, and 8B whatever. Yes?
So if just after I've done the merge, I want to do some unit tests and I don't necessarily want a commit or anything in the history until that's been done. Is that possible?
Oh, so you want to do some unit tests?
My working copy, then do some tests before it.
Yeah. Let's illustrate that. So the question is basically if I want to do the test before the merge on my feature. Yes, let's illustrate that because that's the proper way to do it. Let's back up a little bit. So now, interestingly, because when I merge, all the original commits are still here, right? It hasn't thrown it away, it hasn't smashed them together, they're still all there. I can just say, hey git, let's see, so the commit 8B899, that was where master was at before I merged. So I can use reset, which is the arbitrary move labels around command, and say hard means after you do the switch, also check it out. I can say, hey, move to, what was that again? 8B, nobody remembered? 8B8. Git, reset, hard, 8B8. Whoops. 8B899. Yes. So what I've just done is that. So we're back to where we were before. Interestingly enough, this is still here. I could move this back forward again to it if I wanted to by its identifier. Git doesn't throw things away. Well, it throws things away after about 2 weeks. But you can always get back to where you were before. That's the very important thing. Yes?
When you're moving, let's say you're trying to debug a problem that has been introduced into the code some number of commits ago. Is the correct way to move around within the labels by doing a git reset or by checking out the specific commit the specific commit that you want to look at to try and identify code?
Hold that question. It's a little bit advanced at this point.
Okay.
It's a good question though. The shenanigans I'm doing with moving labels around, they're a little bit dangerous. It's for illustrative purposes. And also for illustrative purposes, I'm going to pretend like this never happened. Okay, so we're back to this situation. The important thing, we're back to the situation where features changed, masters changed, and now we want to do what I illustrated before as the basic workflow, which is in here somewhere. There we are. Isolate, work, update, share. So we've already isolated, we've branched, we've done some work. Now we want to update our feature from master. We want to make sure that our feature still works with the changes in master before we merge it in. So that means instead of merging feature into master, we want to merge master into feature. So we can do that just the same way. You can say git checkout feature. So we're using feature now. And switch. And so feature becomes active, master becomes inactive, and head moves there. Switch back.
Point the camera up a little bit so we can...
Oh, are we? Sure. There you go. This is a continuous problem. I may have to start to, yeah. Doesn't help because it's all still all be there. Right. So switch back, please. So the workflow I illustrated is right. Branch, you check out, you edit, you test, you add, you commit, and then you can simply say merge in from master. All your changes in from master. So we're going to do that. At this point, we're going to say git merge master. And again, we've got a merge commit, just like before, except now we're merging master into feature. And we can just save that and switch. And it did basically exactly the same thing as before, except in this case, it moved feature. A little dubious.
Yeah. So there's a risk at this point it doesn't build.
Right. So if you
But my instinct is that anything in the commit history is something that it builds.
well, see, that's the whole point of a feature branch. The whole point of a feature branch is that, first off, you haven't shared this with anybody.
True.
This is all just sitting on your disk. Unlike Subversion and CVS, commit does not mean share, or as I like to say, inflict. Git does no network until you tell it to. And the only way you tell it to is push and pull.
There's still a point in the history that's of no use to anybody.
What do you mean?
Until it passes tests and does.
Oh, okay. So all right. So the question is, what if this screwed up? What if you do this merge and everything goes pear-shaped? Well, there's two ways to do it. The traditional version control way to do it, and it works quite well in Git, is to just fix it and commit that. But some people would say, oh no, that leaves a bad commit in the history. Oh no, what do I do? So when you're starting, so the problem is when a lot of Git people feel this is extremely important to have a very, very clean history, to the point where when you're starting Git, they overload you with this sort of information about how to rebase and have clean histories and everything else, without really explaining to you how the damn thing works in the first place. So what I would say as beginners, don't worry about it. And for God's sakes, don't rebase until you understand this all down pat. Rebase is really fun and really powerful to get you in bad places. Because what you can do is at this point is you can rebase or rewrite this commit. Now I'm going to show you how to rebase. I'm going to show you the safe-ish way to rebase. So rebase can get you into a lot of trouble because rebase can basically change everything here. So, but let's say that this was a bad merge and it didn't work and everything else. Now, there's a few things that you can do. Well, because it's a merge, it's a little bit weird. We can simply reset, and just like I did before, and just pretend the merge didn't happen. But then it's kind of weird to have to test the merge. You can try and fix it in master and then remerge. Quite honestly, if you've got a bad merge. This is getting off topic.
Yeah, absolutely.
I'll come back to it because this is not the ideal spot to teach rebase. Right. So now that the important thing here though is that we have in this workflow switch. In this workflow, we are at we're at this point. We've merged in from master, we've got our updates, we got our bug fixes and everything else. And let's say that our tests pass and everything works. We can at this point choose to continue working on our feature. Maybe there's a bug fix in master that we needed that was important. Maybe we just want to make sure our feature branch has been open for a while. So we just want to make sure that everything still works. Or at this point we can decide we're done, we're ready. We've already merged everything in with master. We know it's been tested. So now we want to share it with everybody else. We want to commit our feature into master. So let's do that. So you do the same thing we did before. You check out master, and you merge feature. And it did a fast forward. Switch. Because Git looked at this and it went, It looked at this and it went, well, master is a direct ancestor of feature, so all I have to do, there's no merge necessary, again, we already did it, is do that. Now it's great because it means that, oh, sorry, we checked out. Checked out master. Which is great because it means that you tested this as feature, and that's exactly what master is now. There is absolutely no difference. So your tests have to work. It has to be the same. The commit ID is the same. Your test ran on the commit ID. Everything's the same. I see a few nods of heads. I see a few, yes, good, good, good. Get it? Great. That's excellent. There's, I just switch back. We'll do some more merging later, but I want to move on. How much time do we have?
You have got about 15 minutes.
Oh, great. We're in good shape. So Git, one of the interesting things that Git does is that Git has like 9 million different ways to do a merge. And Git will try its damnedest to do a merge in such a way that doesn't conflict. And it doesn't always get it right. Sometimes you can tell it to use an explicit type of merge strategy, especially if you're merging like 3 different things and it's a big mess. But I really just say this because there's one called merge. There's one called octopus merge, and that's yeah, some octopus porn for your enjoyment. Okay, so far everything that we've been doing is on our own local disk. It's on our own local repository, and even though by merging our feature branch into master, I've been calling it sharing. We're not actually sharing with anybody but ourselves. All the isolation and coordination is for our own purposes. When you want to work with others, now you start to get into remote repositories. And the 3 critical commands are push, fetch, and pull. How many people here, raise your hand if you've used remotes and push? Okay, write the hands down. How many people here will raise their hand when I ask them to? Raise your hand. Okay, so but now that I've calibrated that, it means just about everybody's used remotes. Okay. This is where the trouble starts, I think, for most people. Everything kind of goes to hell. Now, first of all, the main difference between the way I've done this repository with init is that normally you clone an existing repository, right? You're cloning it from GitHub or something else. You're getting a copy of it. So I'm going to need another minion to be my remote. A volunteer? Yep.
Hands onward, yeah.
Yep. Still done good here? Right. All right. So what I'm going to do is I'm going to turn this, if I do this correctly. No, I didn't do it correctly. Impromptu lesson here. One of the interesting nice things about Git is that because everything just sort of lives in the directory, I can do something like this. No, that's going to be the work. I can make a directory called work, and I can just move everything into it. And then that all works. Git doesn't care. Everything is still there. Great. Because I made a mistake. So I'm going to fake turning this into a remote repository. Great. Yes. Okay. So what I've just done is I've told Git, hey, make a copy of this, but only. If you look inside remote, this only contains the contents of the .git directory. There's no checkout. This is what a remote Git repository looks like. And I'll show you in here, if we look at the stuff that's in here, you can see in this objects directory contains a whole bunch of files, and those probably look a little bit familiar. They are the hashes of the things we're working on. There's 8B899, which I think is that. And that's how Git stores everything. Git just uses the file system as a really dumb, robust database. And it's pretty transparent in there. But point is, I now have a remote repository. So what's been done, I'm going to get rid of work to do the clone. OK. So normally when you clone, you say git clone and then a location. Now, interestingly enough, Git doesn't really care about what the network is. And in this case, the network is the file system. So I can actually use just another directory as a remote repository in this case. It could be going over SSH, it could be going over HTTP, it could be going over the special Git protocol, it doesn't care. So I'm going to clone remote, and that could just as easily be a URL or anything else. I could write, file : / that makes it easier. And I'm going to clone it into work. Great. So now I have 2 directories, and if I take a look at work, there's all our stuff. There's all our things. There's commit 8B899. So you are going to be our remote repository. And we are going to, what effectively we did is copied all of these things, Probably should have made the thing smaller before I did this. Oh well, it can be exciting. B, and then we have a W. And then what's next? K. Right. Thank you. And then an O and an M.
M goes up. Okay.
Mm-hmm. And then, right, the O is on the side of it. Yep. Every single one of these objects gets copied. Exactly the same. And how do we know they're the same? Because they have the same IDs. Also, our... That's all right.
Question?
Yes.
When you did the clone of remote into work,
Yes?
the work was now an empty directory, right? Or did it already have a
It was empty. It didn't even exist.
Okay.
Just like you're doing a regular clone. The labels also get moved over. Head. So there we go. There's also, okay, so we're going to call you, now when you have a remote, the remote has a name. My clone, the remote has no name in and of itself, but my clone, if I ask it, hey, what are your remotes? It says, I have a remote. Its name is Origin, and it's located here in this directory. The remote, and he's going to be the remote, doesn't know its name. The remote is totally about work. So you, sir, whatever your name may have been before.
Yep.
You're now Origin.
There you go.
That's our remote. This is now our working directory. Two different things, separate. Right. Okay. Now, the important thing to understand is that these are, again, two completely different, completely different things. So something else has happened here. If we look at our Git log, with all the fancy stuff on, you'll notice there's some new stuff here. Origin master, origin head. These are what's called tracking branches. I'm only going to deal with origin master. These are labels just like any other commit, just like everything else, but they're special because what this says is, last time I talked with origin, that's where its label was. That's where master was on origin. And I also, last time I talked to it, that's where feature was. And this is how Git coordinates. This is how Git, without talking over the network, knows what the state of the remote repository is. These are called tracking branches. But they're like any other branch in a repository, like any other label, all the same technology, same tricks.
So when you query that label, there's no remote access or...
Yes. Where did our feature go? Oh, feature didn't get pulled over. Haha. Interesting. I made a mistake. Go ahead.
Can you replace the face of the camera slightly? I can't see the label.
Oh, we can't see? Yeah.
Sorry, but feature didn't get pulled over?
Feature didn't get pulled over in the clone because it only pulls over, because master, it only pulls over really like the default branch, and master is the default branch. Origin and master don't have any real significance. It's just the default. They're just names. I could have as easily called him Alan? Abby. I could have easily called my remote Abby.
Something feature shouldn't be there on the clone?
No, it is because this is the clone.
Oh, okay.
Yeah. We kind of did that backwards.
Yep.
Yes, was there a question?
I didn't get how there are two heads. There's a head on each branch.
There's a head on each. These are two.
On each,
Yeah, because this is a complete Git repository sitting in the directory called remote. This is a complete Git repository sitting in the directory called. You know what? This is weird. I'm going to get rid of it. It's just confusing. Because as far as I can tell, the remote doesn't really do anything with head. So it just sort of clutters up the model here. So let's make a little white lie.
That's not checked out, so it doesn't have head, does it?
It does technically, but it doesn't really do anything with it.
Head is a local.
Yeah. It doesn't.
Only makes sense in combination with the working.
Yeah, we're just removing that from a model because it's confusing. So this is the big trick that Git uses to do remotes. That Git uses to talk over the network. Is it just basically says you have a complete copy of the repository, and I'm going to use these labels to track where everything is. So let's illustrate how that works. First, I'm gonna let's shorten things a little bit. Let's get down to K. Yeah. All the way down. All right. There we go. All right. By the way, if you're wondering what a directed acyclic graph is, it means that a graph is just nodes and lines. Directed means that all the lines have directions. In this case, the direction is down. They only go one way. A node only knows, a commit only knows its parent. It can't go that way. And it's acyclic, which means it has no cycles. You can't do this. There's only one way through here and one way through here. There's no loops. That's it, directed acyclic graph.
It's not a dirty bit on the sheet.
No. Not a dirty bit on the sheet.
It knows about two parents.
Yes, yeah, it knows about two parents. That's okay.
So it's part of its commit version.
It's a very forward-thinking sort of repository. Yeah, commit can have any number of parents. That's fine. So, where were we? We were doing push and pull. So we've just cloned, and I've talked about remotes. So, unfortunately, I have to do it this way so I can see my notes. So getting back to the original Git workflow that I was talking about, we have isolate, and we've already kind of isolated ourselves simply by cloning. We've got the work, which is edit, test, add, commit, repeat. Update, which previously was merged from master. And then share, which before was, well, I can just show you, which before was merge, test it, and then merge our branch back into master. The workflow for remotes is remarkably similar, except instead of merging into our master, we merge into the remote master with push and pull. Because pull is actually a fetch and a merge. So let's see. I'm going to create a third repository here, so we can have somebody who is doing work other than us. Git clone. I'm not actually going to spell it out because it'll just take too long on the thing. So we have. I'm going to clone another repository. Whoops. Great. So we have a third repository, and this represents. Oops. I bear cloned it. Right. So this represents somebody else who is working on the same remote with you, right? Let's go back to our repository, our work, and let's add something here. Let's let's add a new file. Right, and we're doing it in, or being bad, we're doing it in master. Let's make a new branch. Checkout. So I'm going to do it the convenient way. Checkout -b is branch and checkout. So if I say checkout -b bug fix, just use something new. That's the equivalent of branch bug fix git checkout bug fix. It's nice to do it in one step. So now, right here, we have another branch. Nope, you're good. No network communication. Called bug fix. We can now. Yes, thank you. Great, you guys are getting it better than I am. We can add our new file, which will. Thank you. Add in our staging area, just as before. Staging area, the home game. And then we'll commit that. And now it's told us that it's committed to the bug fix branch. It's given us its ID. Flip, just as before. Bug fix moves. Head moves. Everything else stays the same. Probably should have done master for better illustration. Oh well, you'll see. So now, let's say that I want to share this bug fix with other people. Now, what I want to do is push it up into the remote, into Origin. So I can do a git push Origin bug fix. Now, how many people here are confused because sometimes you say origin / branch name, and sometimes you say origin space branch name? Yeah, okay. So, what's happening here is that when you say origin / branch name, you are referring to, switch, thanks. You're referring to this label. This label, which tracks, which is actually just a label on your repository. When you say origin space branch name, you're talking about the remote called origin and its branch on there called bugfix, or we're going to make a branch on there called bugfix. You're referring to them as separate entities, the remote name and the branch name. A little bit weird, but hopefully it makes a little bit more sense now that you understand, you can see the tracking branches. Question?
What would be the difference in behavior between the two?
It's just what each command, well, it's because if a command, say checkout or diff or log, they all work on references. They all want a branch name or something like head or a commit ID or remote ID.
So when you're pushing, you always put origin space bugfix.
Because that's not working on references. It's actually saying I want to push to the repository called origin my branch called bugfix. Yeah, if push origin / bugfix, it would get confused because it would be looking for a remote called origin / bugfix. Not the best interface designers. Question?
If you're currently checked out on the master branch locally and you do git push bugfix, git push origin bugfix,
Yes.
will push your bugfix branch
Yes.
to the remote bugfix branch?
It will push, it will push the current branch, master, and call it bugfix on the remote.
Okay, so to specify something other than the current checkout branch, use / branch name after.
Oh God, I'd say just look at the man page at that point. Yeah, most of these commands work on your current branch. So like for example, git merge master. So for example, says merge master into the current branch, which is bugfix. But I could just as easily say git merge master into feature. Or I could explicitly say merge into bugfix. So that says merge master into bugfix. This says merge master into the current branch, which happens to be bugfix. This says merge master into the feature branch. So most commands have an implicit use the current branch.
As a tip, how do you find out what branch you're currently on?
Oh, how do you find out what branch you're currently on? Git status is the easiest way to do it. It says on branch bugfix. Some people will have special things in their prompt that will be constantly checking what branch you're on. You can also do git branch, and that will tell you all the local branches. And the one that's starred is your thing. You can do git branch -r, which will show you all the remote branches. And I lied because origin feature is there. It's cool. Yeah, I'm going to skip that. And you can say -a, and they'll just show you everything that you've got, all the references that you have. Yeah. Right, so we were pushing. So git push origin. Now if I was just to say git push origin, Git's going to come back and say, I don't know where to push it to. The current branch bug fix has no upstream branch. And the nice thing is that Git 1.7 and up started to become a lot more helpful. So if you're using anything older than 1.7, really, really upgrade, because everything, all the commands got friendlier. Generally, Git tells you how to solve the problem in its error message. So what it's telling you here is it's saying that I don't know what the name of this branch is on the remote, and I'm not going to guess. I'm not going to guess that my bug fix branch should be bug fixed on the origin. I think you can configure it to make that guess, but I don't have it configured that way. So what it's telling you here is it's saying, hey, if you want to, you can run git push set upstream origin bug fix, and then it will remember that your local bug fix branch pushes to bug fix upstream. And that's actually really, really handy. It stores it just in your .git config. So I can say -- set upstream origin bug fix. Actually, that's just that -u. And now it will remember, so next time you can say git push, you'll remember, oh, bug fix goes to origin bug fix. So, push. Okay, said a lot of things. Now network or file system stuff has happened. Now we've shared what we've done. Sharing in Git is very, very consensual. That only happens when you want it to. So it told you a lot of things. The important thing to understand is this down here. It said, hey, I wrote to this path to the remote. That's the repository I actually wrote to. Normally that's a URL. I made a new branch. I took our bug fix and I turned it into bug fix on origin. And I remembered to track that our branch bug fix is going to now forever push to the bug fix on origin.
You can run git branch minus a again, so you can show how that.
There's no.
Oh, it doesn't actually do it.
No, where it stores it is here. Whoops. No. There we go. It's actually stored here in the Git. Each repository has its own config file, and you can see it there. That it says the branch bug fix, its remote is origin, and when you merge it, use, well, refs head bug fix is a fancy, refs head is a fancy way of saying the branch bug fix. And you can actually just edit that if you want to get brave. It's actually not that, it's not that difficult. It's one of the few.
Does that suggest that you can have multiple remotes?
Yeah. Oftentimes I'll have a remote, say if I have a fork on GitHub, I'll have a remote pointing to my repository and a remote pointing to the original repository. Maybe I'll call one origin, maybe I'll call one upstream. Yeah, you can have as many remotes as you want. They can point to the same thing. You can just add them with a remote command. You can change where they point to. You can do all sorts of things. We're not going to talk about that too much.
Is there a dry run if you're just not sure before you push?
Not really. Because, sort of. It's kind of the same flow as before, where instead of before when we merged, we pulled in master to the feature branch and then tested it, and then pushed, and then merged that back into master. You can kind of do the same thing. You can pull, test, and then push, and that's what I'll show you in a moment once we have an interesting difference going on here. So, push does two things. Hold on. Very eager. So push, basically what happens is that this is the beauty of these IDs. Now let's review some things about IDs first. So as I said, every ID is unique. Every commit is unique, right? Commits never change. So that means that every commit can be uniquely identified by its ID. So if I have R, if I have R and, well, he doesn't have R, but if he had R, that means we know we've got the same thing. Flip back.
Can I ask you something? I don't know if it, but where my biggest problem is with it is, so you're referring to things as R and D and M, and that's very lovely. But when I'm working on auditing a bunch of code, I need to actually be able to audit right back for the various commits. So it starts getting crazy when I'm auditing through 50, 60, 70, whatever not. And also the hashes, like I'm having to, when I'm referring to those IDs, I'm actually having to go through, scroll through, and then work out, okay, what is that hash? That's the hardest thing for me.
Right after this, remind me, we'll get back to that, we'll solve that. So every commit can be uniquely identified by its ID. This is really important. If I say I have, BA642, and you go, I have BA642, we know we have the same commit with the same message, the same author, and same date, and same content, and the same previous commit. Really important, because what suddenly happens now is every commit's history can be uniquely identified by its ID. So if I tell you, if I say I have D, and then my remote goes, well, I have D as well, now we don't have to say anything else. We know everything from D on down is exactly the same. And that is why Git is so efficient over the network. Because when these two repositories talk to each other, they basically say this. So they go, hey, I have a thing called master, it's at D. And it goes, I have a thing called master too, it's also at D. Great, we have exactly the same repository. What other labels do you have? I have a bug fix, I have a feature branch, it's at D. I have a feature branch, I have a feature branch, it's also at D. Great, we have the same things. I actually don't have a feature branch. Don't have any further conversation. So when we push, the conversation goes something.
I think you do have that feature branch on your repository. You have the tag for origins last.
Oh yeah, that's right. That's absolutely correct. I actually don't have that because it only checks out the master one. That's why it's so nice to have that git log decorate graph command that I'll show you at the end, because it gets, it's a lot easier to just ask Git what things are like than to try and remember exactly what everything is doing. So with the push, what push is doing is the remote protocol goes something like this. It goes, hey, I'm going to give you some new content. I have this new branch called bugfix, and it has a thing called R. It's on a commit called R. Remote over here says, I don't have an R. And remember how I showed you that object directory, and it was just a directory full of IDs? It's very, very fast for it to find if it has a given commit. It's just a simple file lookup, a directory. It doesn't have to traverse everything. It's just one point. Do I have it? I don't have it. So then it goes, well, I don't have it. Tell me the previous one. This one says, well, the previous one to that was D. And this one goes, I have a D. And you go, great, all I have to send over is R. So here is R, sent over the wire. Nothing else needs to be sent. And then you just get a bug fix label. Whoops. Yeah, go ahead. Right? And I'm going to track. But last time we talked, that's where your bug fix was. Right. That's push. Questions? Confusions?
So just to be clear, if there were other commits between D and R on the repository you're pushing from,
they'd be sent.
Would just copy the entire repository, entire commit history.
It would copy if there was. So the question was if we.
It will copy the necessary.
Yeah.
Commit history.
Yeah. So the question was if it looked like. Would you pull that off? If it looked like this, then what would happen is it would go, hey, I've got R, you don't have R, or I don't have R. Well, before this is F, and it goes, I don't have F. Well, before that is D. It goes, oh, I have D, great. So I'm going to send you F, and I'm going to send you D or R. Yeah, so that's exactly it. That's why it's so fast. It's very, very fast. There was another question?
I was going to ask,
No, I'm getting ahead.
Okay.
What's the active branch on the origin? Is it still master? Or?
On origin, it's a little weird as to what an active branch is on a bare repository. So the answer to that is moo. Yes.
If F was more complex, if it was branch and merge,
That would all get sent.
Send one of those.
No, it would send it has to send the complete history. So just as when I cloned this repository, I got the complete history of it. I have to get the complete history because this merge, I cannot have a commit with the ID of D without knowing both its parent commits, and that means I need to go all the way down. So it sort of takes care of itself. Question?
If F had a branch,
Yes.
your local repository, where you push R, it would send F, but it wouldn't send the branch of F.
Yes.
Because it's not necessary for that. You're only pushing.
Yeah, it would not.
Necessary for the history of R.
Yes, exactly. It would not. If there was a branch deeper in the parent history, it would not send that label. Generally, push doesn't send labels unless you explicitly tell it to, and we explicitly told it to send bug fix. Any other question?
How does Git handle the conflicts? Let's say there is another branch, somebody wrote to foo, and you have also written to foo at the same time.
Well, let's just do that. Did you see if you have enough pieces to build a third repository?
Yep.
I think I planned that out. I may have screwed it up. Right. So this is exactly. Oh, right. Sorry. I wanted to cover Amy's problem first because Amy's problem is pretty simple. So Amy is basically asking, oh God, these IDs. I'm supposed to remember. Did I sum that up well? How am I supposed to remember 147 FC1 DB blah blah blah?
Or even search, like, you know, when you're trying to search.
Right. Well, first off, there are many, many wonderful tools that illustrate all of this. This is called GitXL. Unfortunately, or fortunately, depending upon which side of the line you're on, it's only for OS X. But this basically, again, that looks remarkably similar to that, doesn't it? So this shows all my labels and where everything is at, and I can just simply, let's make this a little bit bigger, and I can scroll through it, and it's going to show me the diffs. So, it's quite nice. There are other things. There's GitK, which is the default GUI. It's kind of ugly. I don't really like it, but it's something. I like a thing called TIG. Do I have TIG installed? Damn it, I don't have TIG installed. TIG, I have, sorry?
So that's what, so basically you're saying jump to the GUI.
Jump to the GUI, well no, that's one thing is to jump to the GUI. This is what TIG looks like. TIG is a totally command line, but it's curses based, so everything can use it. No, what I am saying is tag. So jump to the command line to plow through these sort of things. Sorry, jump to the GUI if you just need to like tick through them all, and it's going to drive you mad. But let's say that you were like, I always go back to this commit because let's say that this commit was a release. Let's say that commit B0823 is when we release version 1.0. Well, what you can do is you can tag. You can say git tag B0, what the hell did I call it? B0823 as version 1.0. And again, like most other Git commands, if I were to just do this, it would tag the current point that I have checked out. And if I do this, it explicitly does another thing. So I tag, and Git says nothing. Thanks, Git. We may have actually gotten rid of that commit, but let's pretend it's this one. Here's what a tag is. Yep, you there? Okay. Doink, that's tag. A tag, what's that?
On the first commit, you released version.
Well, there's there's stuff here. But yeah, bold. So a tag is nothing more than a label like all these other labels. It's the same trick used over and over again, except this one doesn't move.
And you can have multiple?
Yeah, yeah. You can have as many tags on a commit as you want.
Tag is a release. Then I could come in and tag it as broken this or blah blah blah.
Yeah, yeah. So we can go here and be like, hey, FAC blah 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 blah, get tag 0.1 to that, and then that one was the FAC. That was the merge point. I think that was that. Yeah, so there's another tag.
So with any problem like just doing audits, you might want to do this historically like you are now. You're adding tags to an existing, local repository. Do those get pushed through merge?
Only if you ask. They only get pushed if you ask. So I can say git push origin tags, and then it says, hey, I push a new tag to, this is where I push to, this is the tag I had originally, it's the tag that I wrote, and then all of a sudden, this repository.
That one, that's origin.
That's origin? Yep. Put a sticky note on it. That one goes there. And that one goes there. So now they've got it. So now if somebody pulls, I think you have to pull tags explicitly, they'll get the tags back down. Tags have a little bit of trouble coordinating between repositories, but like any other label, it only really comes over if you ask for it. Question?
Can you use those tags interchangeably where you use a label?
Yes. Basically, most Git commands will interchangeably accept what they call a reference. And a reference is a commit ID, a branch, a tag, a remote branch. Any of these things will all work. So I can check out a tag. I can branch from a tag. I can merge from a tag. I can do just about everything with it. The only thing you can't do is move it without forcing, without saying, delete it and make a new one over here. Question?
I was going to ask if you could move tags around.
Yeah.
So you hit one pointing to the current release version.
Yeah, you're not supposed to. I mean, because they're not supposed to move, but you can do it as a force command. Was there? Yeah.
Yeah. So you mentioned just in passing that it's difficult to pull the tags down.
It's not difficult.
If they're just attached to a commit, why?
Ask the Git designers. I really don't know. See, the tags is one of those other things where Git people like to argue about which. There's like 3 different types of tags. There's tags that are labels. There are tags that are actually generate another object. Then you can add information to it. There are cryptographic tags that not just have a label, but they are cryptographically signed. So it says, for example, if you do a release and you do a tag git tag-s, it signs the tag, and I think that actually creates a new object. And that means that not only that was this, this tag here, but I, Michael Schwerin, verify that I actually, this is where we actually released.
So if you pull a tag, or you've got your Git set up so that you're currently referencing a tag instead of a branch or master, and you make a change, you add that change, you commit them. What happens? If the tag doesn't, with the branch, as I understand, the branch will move.
Branch move and the tag will stay where it is. Tag never moves.
Okay, so if you check out a tag, you're both in a tag and a branch at the same time?
No. If you check out a tag...
My question is, if you check out a tag and you make a change, what happens?
If you check out a tag, Git goes, oh God, you're in a detached head state. And what this means... Here's my head. Here's my head. Is that bad? It's not bad. Git just is a little bit overdramatic about it, or maybe I'm a little bit overdramatic about it. So what happened is this. Git has moved the head to here, and there's no branch associated with it. So if you were to commit, there's no branch to move with it. And if you go back to that message, the message again, Git 1.7 is pretty good once you get over its drama about telling you what it's going to do. So it says, note, I'm checking out version 1.0, just like you asked. You're in a detached head state. You can look around. You can make experimental changes and commit them. And you can discard any commits you make in this state without impacting any branches. So basically, and if you want to create a new branch and retain commits, you may now just make a branch. So I'll just show you what happens when you start committing in this state. So
Can you type git status for us, please, and show what it looks like?
yeah, not currently in any branch. And of course, we're at this old commit, so all we have is foo. So if I was, for example, to create a new file and add that, and let's not bother switching because I think we know add by this point. It adds it just like anything else, and then commit it. All right, so it says I committed to, and there's no branch name here, it said detached head. But everything else looks the same. Switch. So what's happened is that, I'll just step it right through. So we're here, here's head, add, created the content just like normal, and it created the commit object, and it moved head to here. But there's no branch. So as soon as we switch, so right now, if I was to say look at this that's going to be a little messy. Let's look at this here. Okay. Nope, doesn't show it. Yeah. So if I look at it in git x, it shows, there's my commit, but there's no branch associated with it. It's just, there's just head there. So if I were to move away, if I were to check out, say, master, Git now tells me, hey, you're leaving one commit behind. It's not connected to any of your branches. Here's the ID and here's the log of it. If you want to keep them, you should create a new branch, and this may be a really good time to do it. And just in case, if you ignored this, you can go into your scroll back and still have that commit ID there. So you can do it even after. So I'm just going to do it. And so it switched anyway. It did it. It switched. So we are now on master. So head has moved to here. We're running out of holes. Let me show that one more time, illustrated with the camera switches. So head has moved from our detached commit here to here. All right. And now switch back.
And now master is the active branch.
And master is the active branch. Thank you. And yep, thank you. And if we take a look at gitx again and reload it, it's gone. That commit has apparently disappeared and been deleted from the repository. Oh my God! But it's still there. Git doesn't throw anything away. Git throws things away that are detached, nothing pointing at it, but it takes like 2 weeks unless you force it to do so. So it's always going to be there. So we can, take this ID and we can still do a git log on it, and it's still there, and all the history is still there. And we can, for example, say git tag experiment to that one thing. And now what we've done, switch. Is we've done that, we added a tag to it, and now it lives. And now it will live forever until that tag gets deleted. But now there's a label referring to it, a reference, so Git will hang on to it. It's just a label, there's still no branch there. Yeah, you can make a branch there just by saying git branch checkout, git branch name 6103, blah, blah, blah. Yeah.
All the time.
Yeah, so that's one of the interesting mysteries of Git. And it comes in handy when you start doing things like rebasing and everything else, because these things still exist. And while I'm at it, while I'm on the subject, how much time do I have?
Just put up the 10-minute signing.
Oh boy, okay. There's a thing called the ref log. A thing called the ref log, which kind of tells you, hey, these are the commits that I've been working on lately. And you can see in there, here's our 6103B1. So basically, this is a way of if something gets really super screwed up, you can still recover the commit and the commit number out of reflog. Reflog is like your rescue. Oh my God, everything's gone pear-shaped. So we only have 10 minutes, Jesus. I kind of wanted to show Rebase. Well, let me take a little poll. Who wants to see more about remotes? Raise your hand. And who, well, come on, get them up there. Rebase is the other option.
Yeah.
All right, Rebase is exciting. Okay, let's do some rebasing. Let's get this back into a state to match what we had. No, yes. So we had 2 commits below this. Look at your phone. Can you get me a stick?
Small or big?
That doesn't matter. Thanks. Probably small better.
I don't have enough smalls to
And green?
copy them.
Green?
Green?
Yeah. Or the yellows. Yeah. Yeah, yellows are good.
Yellows?
Yeah. No, wait, the orange. No, sorry. Fortunately, you can't. These tools are blunt because they're for children, so you can't be stabbed.
Oh, I don't know. Let's see. I believe in
Whoa.
testing.
All right.
Make sure you keep yourself with your blunt instrument.
Oops, that's a duplicate. Can't do that. All right. So, rebase. Let's bring us back to the state that we were in. All right, great. So I'm going to have to do a very simple rebase. There's lots of different uses for rebase. Oh, right, we never actually did this. Okay, back in our state. Isn't it simple? So let's go to our bug fix. I'm going to switch to the thing. I'm going to do a bunch of commands real fast, and then I'll build them up separately. Check out bug fix. Okay. So just to remind you, bug fix just has 1 commit in it, and there. So let's say that we were working on it, and right. So I commit that, add it. Oh, right. So at this point, I should show you, you don't always have to add and then commit. There's, of course, one command that will just simply add and commit everything. It's commit-a, which is very handy.
Go back to the laptop.
Oh, yeah, just keep it on the laptop. Sorry about that. So we've got git status. I say git commit-a foo, and then everything, it'll add, then it'll commit. So that's 1 step. Oh, right. All right, so then we look at this thing and we go, oh, that was dumb. You know, I have a typo. So what we can do at this point is you could just simply fix the typo and commit it, and that's what you would do in a traditional version control system. But in Git, you can do what's called a rebase. So switch to the camera again. Yep. So the state of the repository right now, add, commit, boot bug fix, it's the active branch. Where's head? Where's head? There's head. All right. Okay. So that's where we're at. That's the typo mistake. So first thing I can do is I could just simply commit another one on top of that, or I can switch back. I can do it a really cheapo way. Now, you know what? Let's do that. Let's do it the first way first. Let's do it the obvious way. So let's say I just fix it. 0 bugs found. Commit that. Typo fix. All right, and now in your log you've got typo fix, and then it's like, well, that's stupid. So now you can do what's called a rebase. And rebase has been told as this rewrites history. And doesn't rewrite history, it creates new history because you can't change a commit. So we're going to do a thing called an interactive rebase, which is rebase-i, 5 minutes. And we're going to say, all right, go back from head, and then here's in Git how you say, go back 1 commit, 2 commits. 2 commits should be enough. All right, so it pulls up an editor, and like most Git things, it's very, very verbose and falling all over itself to be helpful to you. So what's going on here is that everything in this comments is just help. Whoops. until I screw everything up. Let's try that again. What's my status? Good. Okay. So what it's saying here is that it's saying this is the command that I'm going to run on this ID, and here's the log message. So at this point it's just saying, so what Rebase is really doing is saying, I'm going to replay these things as if they were patches, one on top of the other. Play them all over again. So this says, yeah, just play this patch and just play this patch. And if I was to just do this, Git would go, well, there's nothing to do, so nothing happened, because you didn't change anything. So what I really want to do is say, I want to take this typo fix, and I want to squash it into the previous commit. I want to take the entire contents of this patch, this diff. So if I would just take it as a diff, I want to patch that into this previous one, and so that there's only one commit here. Make sense? Now I tell it to do that. I save it. So now what it's doing is it has created a new commit. Switch, please. It has created a new commit. It must create a new commit because the content has changed. It's created a new commit here because we were rebasing 1, 2 back. So these are the two things we're rebasing. And it contains the combined content of these two things squashed together. But it has to have a new commit ID. And because it's a new commit, switch, it said, all right, this is a combination of two commits. Here's the first commit message, here's the second commit message, and now we're writing the new commit message for this thing right here. So I don't care about the typo fix, so there we go. I save that. And it's successfully updated. So now it's done this.
It's detached.
And now that's detached, and that just hangs around in Oblivion. What's that? Yes, it did. Successfully if you switch back. It says, successfully rebased and updated REST heads bug fix. Yes. So if we look at it here, you can see that now it's bug fix, origin bug fix, origin bug fix. Oh, this got moved to the wrong place. Out of room.
I think you missed a commit.
Yeah, I think I missed a commit. Don't worry about it. I'm just going to throw this away for the moment.
Sorry, isn't
Oh yeah, there's a.
the reference package?
Yep. What happened here? What did I do?
You had another commit after.
Yeah, we've got 1 minute. This is sorry, I didn't have it set up properly. But the idea, as long as you basically get the idea that a rebase creates a whole new line of history. And the problem with it, here's the really key thing about a rebase, is that so let's say that. Right, so let's say the rebase is R. Yeah, this is good, this is good. So let's say the repository looks like this, right? And now I've rebased, right? And here's D. So I go and I say, hey, I'm going to push my bug fix to this remote. And so I say, all right, I've got a bug fix branch. Its ID is H. And the remote goes, I've got a bug fix branch. Its ID is R. I go, oh well, it's different. Well, let's try and find something in common. Like, well, my parent is D, and it goes, well, no, that's not right. Yeah. I've screwed this all up. I don't have time to explain it properly, sorry. Basically what happens is that because these two things are different and they might not have the same ancestry, now it just goes, they have nothing in common anymore because you pushed, if you pushed this to me and now you're saying that you're over here, I can't find anything in common with them, so I don't know what to do. So the takeaway from this is, once you have pushed, don't rebase ever again. It'll screw everybody up. And in fact, Git will stop you if you try and push after your rebase and it gets into this confusing situation. Git will stop you to do it, and you'll be really tempted to just force it. And if you force it, then everybody else who's working at that repository is now, when they pull, going to get messages that are all, oh my god, the repository is all different. They'll have to force So don't rebase until you're full. We have time for questions?
We do have time for a few questions.
Okay. Thank you for staying for the marathon. Thank you for dealing with... Did an excellent job.